Numerical series with positive terms. Lesson SNP 5. Says the sum n equal 1 from infinite an general term with n greater or equal 0 and belong set natural numbers. To determine the nature of next series, the sum n equal 1 from infinite 1 divided to n minus 1 multiplied to n at 1. Fraction break down into simple fractions where 2n minus 1 multiplied to n at 1 equal r divided to n minus 1 b divided to n at 1. Denominator common to n at 1 to n minus 1. 1 divided to n minus 1 multiplied to n at 1 equal to n minus 1 to n at 1 multiplied to n at 1 b multiplied to n minus 1. Numerator equal, denominator equal, numerator equal 1 equal r multiplied to n at 1 at b multiplied to n minus 1. Replace n equal x belongs to real numbers. 1 equal r multiplied to 2x at 1 at b multiplied to x minus 1. Denominator common 2x at 1 multiplied to x minus 1 equal 0 from x1 equal minus 1 divided to x2 equal 1 divided to root in relation to x equal 1 minus 1 divided to replace 1 equal r multiply minus 1 at 1 at b minus 1 minus 1 b equal minus 1 divided to from x equal 1 divided to replace in relation to 1 equal r 1 at 1 at b multiply 0 r equal 1 divided to result n equal 1 divided to n minus 1 to n at 1 equal 1 divided to factor common 1 to n minus 1 minus 2n at 1. n equal 1 divided to term general from series. From n equal 1, r1 equal 1 divided to 2 multiply 1 minus 1 minus 1 2 multiply 1 at 1 equal 1 divided to 1 minus 1 divided 3. For n equal 1 in relation to replace in relation to n equal to r2 turn r2 equal 1 to 1 2 2 minus 1 minus 2 2 at 1 equal 1 divided 2 1 divided 3 minus 1 divided 5. From n equal 3 r3 equal 1 divided 2 3 minus 1 minus 1 divided 2 3 at 1 1 divided 2 1 5 minus 1 7 n equal 4 r4 equal 1 divided 2 1 2 4 minus 1 minus 2, 4 up 1 equal 1 divided 2, 1, 7 minus 1, 9. 5. 1 divided 2, 1, 2, 5 minus 2, 5 up 1 equal 1 divided 2, 1, 9 minus 1, 11. The sum, 1 minus 1 divided 2, 1 divided 3, 0, 1 divided 5 minus 1 divided 5, 7, 7, remain 1. First, from in n equal n minus 5, n minus 5, 1 divided 2, 1, 2, n minus 5, minus 1 minus 2, n minus 5, up 1, equal 1 divided 2, 2n minus 11 minus 1, 2n minus 9. N equal n minus 4, n minus 4 equal 1 divided 2, 2n minus 4 minus 1 minus 2n minus 4 up 1 equal 1 divided 2, 2n minus 9 minus 2n minus 7. N equal n minus 3, n minus 3 equal 1, 2, divided 2, 1, 2, n minus 3 minus 1 minus 2, 2n minus 3 up 1 equal 1 divided 2, 1, 2n minus 7 minus 2n minus 5. N equal n minus 2, n minus 2 equal 1, 2, 2, n minus 2 minus 1 minus 1, 2, n minus 2 up 1. N minus 2 equal 1, 2, 2, n minus 5 minus 2n minus 3. N minus 1, 1 divided 2, 2, n minus 1 minus 1 minus 2n minus 1 up 1. N minus 1 equal 1, 2, 2n minus 3 minus 2n minus 1. N 1 divided 2, 1, 2n minus 1 minus 1, 2n up 1. Remind R1, R2, sum of the scope equal 1 divided 2 factor common. Remind first 1 minus 1 2n up 1. As the sum series is limit and n infinity R1 R2 n equal limit and n infinity 1 divided 2 1 minus 1 2n up 1 equal 1 divided 2. Finally, the series is convergent. Limit partial stakes. Sum is 5. Series is convergent. Method 2. Apply criterion rapid Bulama. Rabbe Dulama. Limit method 2. Limit and if you add I divided Rn at 1 minus 1 equal lambda. Case 1 lambda greater 1 C is convergent. 2 lambda less 1 greater 0 divergent. Rn equal 1 2n minus 1 2n at 1 Rn at 1 replace n at 1 divided 2n at 1 minus 1 2n at 1 equal 1 2n at 2 2n at 3. Limit n then infinity n Rn divided n at 1 minus 1 equal limit n then infinity n 1 divided 2n minus 1 2n at 1 inverse 2n at 1 2n at 3 1 minus 1 equal limit n then infinity n 2n at 3 minus 2n minus 1 denominator common divided 2n minus 1 equal limit n common infinity n 2n at 3 minus 2n at 1 divided 2n minus 1 equal 4 divided 2 equal to greater 1 CA is convergent according Rabbe Dulama criterion